chain together. So it has like this little tiny compound, but the thing about this is it's hydrophilic, which means it loves water, and when we add 100 milliliters of water to it, it absorbs it. It's a super absorbent. It absorbs up to 500 times its weight. So what happened was that when I added 100 milliliters of water, it's about this much, and this expanded so fast, and it went from this to this. So this is the kind of stuff, the fake snow that you see on like movie scenes and things. So if you want to feel it, it's really soft, and it's actually the same type of thing you find in baby diapers. So that's why, like, if they go in the pool, like, you know, the ocean or whatever, it absorbs because it's a super absorbent, which makes it really useful. So we also have a really cool experiment going on over here.
So that's just to tell you that it can behave as both a solid or a liquid depending on how much oxygen. And again, that's also based on the viscosity. But you know, it should be fast. Actually, a good simile that I found online doing a little research on this is that you can compare it to quicksand. That if you ever get stuck in quicksand, don't panic or because what ends up happening is as you dig around, you start going slower. Because if you think of it like this, that you see how there are chunks here? If I start moving it slowly, it stays like this. Whereas if I used to just leave this here, the spoon would say maybe 6 inches but you let it sit, and then you see how there's a solid, there's a lot of resistance. So the second you stop putting resistance, in this case, in like a big lump of it, it behaves really well. Oh gosh. So if you ever stuck in quicksand, they usually say to spread your body out so the weight is spread out, but also by applying less pressure, you're making it less like a weight. So it kind of behaves differently whether you're moving it in your hand or as a body.
Did you have any questions? Do you want to hear about the experiments?
Can you go ahead?
Sure. So what we have here is we have some dry ice pellets. Dry ice is carbon dioxide in the solid form. And what's happening here is the dry ice, carbon dioxide pellets are going directly from solid to the gaseous state, which means they sublime. They sublime. So instead of going from solid to liquid to gas, they're going directly from solid to gas. You'll very rarely see carbon dioxide in the liquid state, only at, I think it's about like 500 atmospheric pressures, which is unnatural. Normal atmospheric pressure is about 1 atm, 1 atmospheric pressure. So basically in here, this is all carbon dioxide, which is what we breathe out. So what we have over here is we have a whole bunch of water. We have some dye in there. We added a few carbon dioxide pellets, and basically it creates like a frozen water vapor as it's going into like the gaseous state and freezing everything. And what we have here, we have this is sodium polyacrylate polymer, which means it's like a whole bunch of them all stuck together, polymer. And this is very hydrophilic, which means it loves water. So when I added about 100 milliliters of water, which is about to like right here, as you can see, it expanded because it absorbs about 500 times its own weight. And so it went from this to this. And if you feel, this is the kind of stuff that they use on like movie scenes, on like the sets and all that. It's really soft and it feels really nice. They also use this. They have a type of polymer like this in baby diapers. So if they go in pool or like an ocean or something like that, that's why their the diaper gets like saggy or whatever because it fills up with all that water. So it's pretty cool. So we also have a really neat experiment over here talking about pH. If you want to check that out.
Yeah.
Hello.
Hi.
Do you know what pH is?
No.
pH measures the amount of hydrogen concentration in different solutions. So this is lemon juice here. So something with a lower pH has a higher hydrogen ion concentration in it. Have you ever heard of viscosity? Which is here. Viscosity is basically the indicator tells you it has a lower pH. And then the base one has a espresso, but if I stick it in the toothpaste, now kind of
acids and base. Acids and base. Yeah. I heard like water is number 7.
Around 12.5, which it has
anything
baking
lower is
soda.
a base,
And
and
then
everything higher is acid.
Anything higher is base.
Anything higher is base. All right.
Acids and bases have different hydrogen ion concentrations. This can be really useful.
I heard that base actually
because it
burns more
tells
than
about how
acid does because
different
it actually stays on the skin.
compounds can react.
That's the way it is.
donate or accept hydrogen ions, which is hydrogen ion donation is the definition of an acid, and hydrogen ion acceptor is a definition of a base.
Nice. Free ice cream. Enjoy some ice cream when you're done over here.
Neat. Thank you.